So we want to do 36 and 12.5, which has different functions, but is apparently basically the same thing as 34, right? Okay, so I want to calculate my bits and pieces here. All right, so what's f plus g? These first couple should be pretty easy, right? Okay, so if I'm doing f plus g of x, I remember that's f of x plus g of x.
It's x over x plus 1 plus 1 over x.
Okay, so you write the rule down for f, add it to the rule written down for g. So that's going to be x over x plus 1 plus 1 over x. You could find a common bottom here, right? Or not. Whatever. Okay, I'm good with that one either way. How about f minus g? Same thing, but
with a subtract with minus.
yeah, with a minus sign in the middle. So that's x over x plus 1, right? Minus 1 over x. Are these parentheses that I put in here for some reason, are they necessary?
Not
No, not at all.
makes you feel better.
I'm not sure why I put them in there, actually. Some kind of weird muscle memory thing. All right, how about f times g?
The same thing, but with a multiplication symbol.
Okay, so write down the rule for f, multiply it by the rule for g. What can you do at this one?
It's x over x squared plus x.
I would advise for cancel more than multiply it out, right? So x over x is a onesie, right? Okay, so this is 1 over x plus 1. I should probably notice that this thing, right, at this step, had a domain restricted to being not 0 or not 1, negative 1, right? You guys see that? The bottom can't be 0, right? Okay, so this one doesn't have that domain restriction, so I should probably add a little note. X isn't allowed to be 0 here. You guys see that? Because otherwise I've actually fattened the domain up a little bit. I put an extra point in the domain when I canceled that. If I really actually mean equality here, I have to note that little oh, except that x couldn't be 0 anyway.
Do you want it, would you mark us off if we didn't put x cannot equal 0?
Not at this stage of the game, but if we get to calculus, yeah, I might complain about that. All right, how about d?
X over x plus 1 over 1 over x.
Very nice. Okay, so this would be the rule for f, right, divided by the rule for g. And maybe on this one, the parentheses are a good idea.
Then we can like flip 1x and then
Squared over
multiply
x plus
instead.
1.
Okay, so this would be
X squared over x plus 1.
good. X over x plus 1 times x over 1 gives me x squared over x plus 1. Cool. And again, actually, in that flipping over and multiplying, you guys see over here, x wasn't allowed to be 0 because that would cause division by 0, right? Over here, there's no such problem, right? So really, I should also add this restriction. X can't be 0 in this one either.
No negative 1.
Yeah, x already can't be negative 1, right? That's going to be in the native domain. But here I changed the native domain. So be a little careful when you're flipping things over or when you're
X isn't a number,
canceling.
you're okay.
I'm okay with most of the numbers. It's just 0 that's causing me hang-ups. All right, how about this guy? If I want to do f of g, what do I do?
Just substitute 1x into whatever the x's are for x over x plus 1.
Okay, so we want to go into the rule for f, and we want to stick the rule for g in for all the x's, right?
So it's 1 over x over 1 over x plus 1.
Okay, so 1 over x over 1 over x plus 1, right? And then this sucker has compound fractions in it, so I should probably try to simplify, right? Okay, so how do I try to simplify this? You guys remember
Multiply-
chapter 9?
Multiply the bottom first, or the right, the one by x over x. So you want to turn one to x over x so you can actually add the two of them and
Okay.
make them the same thing.
So we want to write this as, all right, this is 1 over x over 1 over x plus x over x.
Mhm. And then you can combine that to x plus 1 over x.
Okay, so I got now 1 over x over 1 plus x over x.
And then you can flip it over and multiply it by the top.
You guys all see that? Okay, so I can say, all right, this is 1 over x times x over x plus 1.
And then it's just 1 over x plus 1.
And this is 1 over x plus 1. And
And x
And-
cannot be 0.
yeah, and I should worry that x can't be 0 here again. You guys all see that? Cool? Questions, concerns, things?
I think that probably didn't quite catch all of that.